Hi, this is Janice Mitchner, and today we are working with Finite, section 8.1, and this is actually a continuation of something that you already are familiar with. It's called Bayes' formula, and hopefully you found your page in your notes that we're going to be working on. And today for homework you're just going to have a worksheet, and then we'll continue with this during the next period. Okay, there's a lot of reading in these, so you might want to pause every now and then so that everybody can have a chance to read the problem before we start the problem. So here we go. First of all, we're going to start with example 1, where we have given 2 urns. Suppose urn 1 contains 3 black and 6 white marbles. Urn 2 contains 3 black and 1 white and 4 yellow marbles. We select an urn at random and then draw a marble. What is the probability that we obtain a black marble? So looking at example 1, again in Bayes' theorem, I'm going to really suggest that you use a tree diagram. So hopefully you're a tree diagram person. So I'm going to sit here and I'm going to think, okay, I either have urn 1 or I have urn 2. Now, it doesn't say that one's more probable than the other to be selected, so I have to assume equal probability. So I'm going to put in my probabilities as I go in my tree diagram. Now in urn 1 I have 3 black and 6 white marbles. So I know I have 2 choices, just black and white. And I have 3 black out of a total of 9, so that would be a probability of 3 over 9, and this would be a probability of 6 over 9. And then from here I'm going to branch off. In urn 2 I have black, white, and yellow. So I have black, white, and yellow. Whoops. And the probabilities of those would be, see, 3 black out of a total of 8. And then I have 1 white out of a total of 8. And 4 yellow out of a total of 8. Now remember, those 3 things right here, double check 3 eighths plus 1 eighth plus 4 eighths. Make sure that those add up to be 8 eighths, which they do. Okay, we select an urn at random. That's how I knew it was just a equal probability. And then draw a marble. What is the probability that we obtain a black marble? So if I look here, let's decide how many ways can we get a black marble. So if I go this, oh, that's not very thick. Let me go to a highlighter, kind of thick. So if I can go this route, and that doesn't show up very much either. Just a minute, I'll get this right. Let's go maybe green. Try the green one. Yeah, that works. There's a black marble in the end, and here's a black marble in the end. So those 2 routes, what I can get is urn 1 and then a black marble, and urn 2 and then a black marble. So if I want to find the probability of getting just a black marble, I'm going to take urn 1 black plus urn 2 black. So urn 1 has a probability of 1/2 times the black, which would be 3/9, plus urn 2 would be 1/2 times getting a black marble there, and that would be, what was that on that one, 3/8. Now on these that I'm asking you to go ahead and find the actual answer, I would definitely reduce these fractions. So I'd get 1/2 times 1/3 plus 1/2 times 3/8. Oh, I don't know if that's helpful. 1 over 6 plus 3 over 16. Well, my common denominator I know is 48, because I know 6 times 8 is 48, and 16 times 3 is 48, so I'd have to multiply 3 times 3 to get 9 for a final answer of 17 over 48. I have no idea how to stop this thing from looking for this network, so we're going to keep seeing that popping up all the time. So our final answer is 17 over 48. Alrighty. Really nothing new on that problem. That we have seen that before. Okay, let's go on to example 2. Example 2. Why don't you stop the video and give everybody a chance to read that long paragraph. Okay, hopefully that your person running the video did stop, and now we're going to make a humongous tree diagram, and this is a lot of information. A lot of people would look at this big paragraph and say I'm not doing this problem just because it's a paragraph to read, but it's not so bad once you get started. So just make sure you start on the far left side of your notes. It says here that when Harry met Sally, they decided to see a movie. They could go either to two theater can't even read myself. They could go to either of two theater complexes, one uptown and one downtown. So I'm going to stop and say, okay, I'm either going to go uptown or downtown. Okay. Now, if they go uptown, they're showing films A, B, and X. So uptown, I have films A, B, and X. And another downtown showing films A and B. So downtown, they're only showing films A and B. So that's what I have on my diagram so far. They decide to flip a coin to pick a complex. A head is uptown, so when I flip a coin, I'm assuming it's a fair coin because they didn't tell me anything differently. So I have probabilities of 1/2 and 1/2 on each of those. Let me put those a different color so we can see those a little bit later. After picking a complex, they roll a fair die to select a movie. Now this is kind of complicated. If they are uptown and on their die they're going to get a 1, 2, or 3, they're going to see movie A. Okay, so stop and think about it. On a fair die, the probability of getting 1, 2, or 3, well, that's going to happen 3 times out of 6 because we kind of add the probability 1, 6 plus 1, 6 plus 1, 6 together to get that. Then they're going to see movie A with a probability of 3/6 or 1/2. Now, if a 4 or a 5 comes up, they're going to see movie B. So that's going to be a 2 out of 6. And they see movie X if a 6 comes up. So that's going to be a 1 out of 6. So there's my probability on those. If they are downtown, they will see A with a 1, 2, 3, or 4. So if your die, when you roll it, if you get a 1, 2, 3, or 4, you're going to go see movie A, so that would be 4 out of 6 for that probability. And you're going to go see a B if a 5 or a 6 shows up. So that's going to be, whoops, I said 5 and wrote 5. So that's going to be a 2 out of 6 for that one. Okay. After the movie, they will, oh, here's more now. After the movie, they will see a late night snack. If they see movie A, they will go to a delicatessen for the snack. Okay, so that's a given. They're going to go here to a delicatessen. We'll call it DE for delicatessen. And you know that's a definite, so that's a probability of 1. If they see B or X, they are equally likely to go to the delicatessen or to a sushi bar. Okay, so we're going to go either DE or S on these two. Equal probability. So that's going to be 1/2, 1/2, 1/2, 1/2. Okay, now keep in mind if I'm going too fast, all you have to do is pause. Just let the person know that's running the mouse that you need for me to slow down. Okay, gosh, down here, did I miss? I kind of lost my place here. So I guess it doesn't matter if they're uptown or downtown. They definitely, if they go to A, they go to a delicatessen with a probability of 1, or they go to a sushi bar or a deli if they go to movie B. So this probability is 1, this would be 1/2, 1/2. Wow, that is one big tree diagram. Find the probability they see movie B, the probability they eat at a sushi bar, and the probability that they see movie B and eat at a sushi bar. Okay, so if I look at this, this is what they're asking me to find. The probability that we go to movie B. Well, to go to movie B, I'm going to use my highlighter again since I can't point, since I'm not there. To go to movie B, that would just be this branch and this branch, plus this branch times that branch. So if I look at that, I'm going to say, okay, how did I get in that top branch? Well, that's going to be 1/2 times 2/6, and the bottom branch would be 1/2 plus 2/6. Oops, no, 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 times. Okay, so let me reduce those fractions. That would just be easier. That I would have 1/2 times 1/3 plus 1/2 times 1/3. So I get 1/6 plus 1/6, which is 2/6. Now what's 2/6 reduced down to? We could reduce that. Okay, sushi bar. I said sushi bar, is that right? Yep. Okay, to go to a sushi bar, I'm going to highlight that in, oh, I can't do any of those fun ones. Let's go to the sushi bar with a highlighter of, I don't know what's going to show up, maybe orange. I don't know if that shows up very well for you. Let me try something else. How about bright yellow? That should show up. Nope. Okay, we'll kind of do this pinkish color. The probability of getting to the sushi bar, let's look there. Well, I could go this way. Oh, that's not what I wanted. How about I just put a check mark at the end? All this is not working. It's not showing up very well. So those are the three ways I can end up being a sushi bar. Okay, so you multiply all those branches all the way out there, all those branches together to see what we get, and then we add them. Okay, so the probability of getting S at the very end, those check marks that I have in red, that's what we're going to add together. So the probability of S is going to be 1/2. Instead of 2/6, how about I go ahead and write my 1/3 times my 1/2, or I have 1/2 times my 1/6 times my 1/2 plus my 1/2 times my 1/3 times my 1/2. So what I'm getting there is going to be my 1/12 plus 1 over 24 plus 1 over 12. So that's 2 over 24, 2, 4, 5. So I get 5 out of 24. Now the next one is that we see a movie and eat at the sushi bar. So if I go back here, I'm going to put a, hey, let's get out the fun ones. Let's put a smiley face at the end of the ones that you eat at the sushi bar and go to movie B. So that would be this one and this one. So I'm just going to take those two branches, multiply all those branches together, and then add the end results. So this is actually finding the probability of B, not B, what do we use? B for movie B with eating at the sushi bar. So that would be a 1/2 times a 1/3 times a 1/2 plus a 1/2 times a 1/3 times a 1/2. And then I add those together. So I get 1/12 plus 1/12, which we all know is 2/12, which reduces down to 1/6. There we go. Okay, that was really a long problem. Okay, on the next one, again, you could read those little boxes and everything. I'm going to go on to example 3. Of the applicants to a medical school, 80% are eligible to enter and 20% are not. Okay, I'm going to stop right there. This is example 3. And I'm going to start, again, my tree diagram. I'm either eligible for an E or I'm not eligible. We'll put that little bar on top of the E. Now it says we have 80% are eligible, so I'm going to put a 0.8 there, and 20% are not, so I'll put a 0.2 down there. To aid in the selection process, an admissions test is administered that is designed so that an eligible candidate will pass 90% of the time. An eligible applicant, so I'm up here, they will either pass or fail. An eligible candidate will pass 90% of the time, so I put a 0.9 there. Now remember, those two have to add up to be 1, so down here the eligible candidate failing is only going to be 0.1. And then not eligible candidate or ineligible candidate will pass only 30% of the time. So again, I put pass and fail as my options for my tree diagram there. And I have a 0.3, and those two have to add up to be 1, so I have a 0.7. Okay, so the first question, part A, says, what is the probability that the applicant will pass the admissions test? Well, passing the admissions test, I'm just going here on my check marks. I just need to do those two branches. So the probability of passing is going to be 0.8 times 0.9 plus 0.2 times 0.3. And this little bar looks kind of funny. That means ineligible or not eligible. So 8 times 9 is 72. Move the decimal 2 places, so I get 0.72. 2 times 3 is 6. Be very careful on this one. A lot of people would just put 0.6, but remember you have to have 2 places to the right of the decimal, so it's 0.06 to get a final answer of 0.78. Okay, that's part A. Part B. What is the probability that he or she was among those eligible given that the applicant passes the admission test? Okay, now, we have done these problems before. These are not new at all. Part B is asking, what's the probability that you were eligible given that you passed it? So what I'm trying to find in doing this problem is the probability of E and P divided by the probability of passing. So I look at this and I think if I'm using the formula, both eligible and passing would be 0.8 times 0.9 divided by all ways of passing, which we just found out that answer. I don't think we need to do it again, 0.78. Eligible and passing divided by just the probability of passing. So I get 0.72 divided by 0.78, which is just 72 over 78. Now, if that bothers you and you want to reduce it, it's 12 over 13. Now, did I really have to use a formula? And that answer is no. Because I could go up here and say, okay, where is eligible and passing? Let's put a smiley face there. This is eligible and passing. You put the smiley face over the check marks. So you find out in your tree diagram where is it happening both at the same time, and you put that multiplication, that product of all those branches divided by the product of the branches of the check marks. That is Bayes' formula, and it's nothing really new that we've already done. Now, one thing I do want to point out when I'm looking at a tree diagram, and you might need this when we do homework a little bit later. So this is just kind of like a pause. Okay, FYI, fun piece of information here. I'm going to do this one in green. This area, that little value right there, 0.9, that is actually the probability of passing given eligible. Okay, that's what that's just 0.9. Okay, now what did we just find in our problem? We found the probability that they were eligible given that they passed. Do you see the difference between the two problems? Eligible given passing, we had to actually do a lot of mathematics there, but when we have the probability of passing given that they're eligible, we just had to look right there at the tree diagram, and that is 0.9. Okay, we are ready for example 4. Okay. Example 4, please, whoever is running the computer, please pause so everybody can have a chance to read this. Okay, so here we go. A faculty member at Gigantic State University regularly teaches an evening course in a neighboring city. Each time he makes a trip, he is randomly assigned an automobile from the university motor pool. The motor pool consists of 50% Chevrolets, 30% Fords, and 20% Volkswagen. So let's stop right there, and I'm thinking tree diagram. I have Chevrolets, I have Fords, and I have Volkswagens. Now, I'm not going to use percents, I'm going to use decimals, 0.5, 0.3, 0.2. Some of the cars are air conditioned and others are not, so that we either have air or we don't. We'll put a frown for that. Air or no air. Air or no air. Okay, guess I should put no air. It says that some of the cars, let's see, 60% of the Chevrolets have air, 40% of the, no, 50% of the Fords, and 30% of the Volkswagens. Now, do I really need to do the other part? I don't think so. Okay, one afternoon a faculty member is assigned an air-conditioned car. Now be very careful. That is the given. We have air. What is the probability? Is it a Chevrolet? So that's what we're trying to find. So I'm thinking, okay, in my denominator, let me not take up so much room on that. In my denominator, I'm thinking of all different ways that I can have air conditioning. So in my denominator, I'm looking up in my tree diagram, air conditioning. How am I ending up? Check mark, check mark, check mark. That's going to go in the denominator. What am I trying to find the probability of? What is the probability that we have a Chevrolet? So what's going to go in the numerator? I'm going to put a smiley face by what's going to go in the numerator. Okay? So in the numerator, I have 0.5 times 0.6. That's when they both happen at the same time. That is my C intersecting A. In my denominator, it's all ways of getting an A as my end result. 0.5 times 0.6, 0.3 times 0.5, and then 0.2 times 0.3. So what I get here is a final answer of 0.3 divided by 0.51. Now be very careful when you're doing this, when you're simplifying this. That is 30 over 51, which reduces down to 10 over 17. Okay, so what I want you to do is I want you to work in groups if you have time on numbers 5 and 6, and then I'll have the answers up here in a second. Okay, go ahead and do that. Oh, that means you need to pause the video. Okay, just real quick to check answers. Here is my tree diagram for number 5. And notice I don't even fill out the second part of that second branch of the tree diagram. And this would be more of a setup only because of our strange little numbers that we have here. We definitely need a calculator on that. Pause that if you need to look at it more. Whoops. And then here is my setup for number 6. This one I would expect you to go ahead and find an answer. Okay, final answer that I got on this one was 15 over 35, which reduces down to 3/7. Okay. So you have for homework, I do believe you have a worksheet, so you can go ahead and get started on that. Thank you very much. See you later.